This is a chamber I helped a faculty member at Murray State build. It's for testing CO2 flux inside the dirt based on dirt cracking patterns. So this is a smaller chamber that's just temperature controlled, but doesn't have CO2 measurements. Basically what happens is you put dirt inside of here in liquid form. So it's just basically mud, and then you, over a period of time, we're examining how the dirt cracks, and we have a web camera for that, which is going to be integrated inside this system. The advantage of this system is obviously we have significantly greater build volume than the other chamber. We can fill this entire area with dirt. And then we have CO2 sensors like this one right here, where we can measure the CO2 flux by shutting off this valve right here. So the entire system is going to be fully enclosed. And then over a period of time, it's going to measure the CO2 flux inside the dirt. This is a study that hasn't been done before. All the signals are going through an Arduino for processing. So right here we have an Arduino Uno, and that's measuring the temperature and humidity, and then keeping within a set range that you can set using the program that I developed. And all the data is going to this computer where we have Excel running as a data like processing unit. So it's taking all the data from the Arduino and then just typing it out. So you have the live temperature readings, live humidity readings, and live CO2 readings, and also whether or not the chamber is shut. So it's set up for every 30 minutes, this shuts for 2 minutes, and then during that 2 minutes, the chamber is fully closed off. Whenever we manage humidity, this is for if it's below the set percentage of humidity, and this is if it's above, it's just dry air coming in from a pressure system inside the building. And we also have a barometric sensor inside of it to make sure that the pressure inside the sensor, or the system that's coming from that pressurization system inside the building from the compressor, never exceeds a certain percentage. I put it as just 1 psi. And this is the heater unit, which turns on if it's too hot, and if not, then it will just naturally cool down. We have a bunch of gaming computer fans that we're using to circulate the air within the system. And right now we just have some dirt to test the drying capability, or some water to test the drying capabilities of the system, because we are planning to just pour in the dirt in mud form and let the water come out. Make sure it's like a level consistency and such. Everything's going to be shrunken down significantly. How we actually are controlling the appliances is interesting. We have an electrical outlet I can actually show you over here, where it's going into a relay. So what's happening is we got mains power coming in here. So that just plugs into any of these outlets. And then we've got the live wire going into this relay. And whenever this 5-volt signal from the Arduino activates it, it passes the live electricity from the mains through this, completing the circuit on the outlet. And you can just plug whatever you want into this. And we just have 5 of these controlling 6 appliances. And we're planning to integrate this entire thing into a single box, instead of just having multiple outlets. It's going to just be one single box with all the outlets, all the relays, everything all integrated into one piece. But the system is currently fully functional.